Before starting, update ComfyUI, so all the native nodes of Wan are up to date. It is possible that after the update you have an error in relation with an update of the frontend. Follow the instructions of the message and update the requirements manually. For questions, please check the issue post in the ComfyUI GitHub. Link in the description. I also leave a link to the ComfyUI examples page, which contains the instructions and workflows of Wan. There you have the links to the different models and where to install them. Download the UMT5XXL FP8 text encoder and the Wan VE. If you want to make image to video, you will also need the Clip Vision H model. Click in the link and download it from Hugging Face. From the examples page you can access SafeTensor's copies of the different models. For image to video, you have 4 models. 2 of them are tuned for a resolution of 480p and 2 for 720p. For each resolution, you have a BF16 and a FP8 models. The lower the resolution, the less VRAM required. FP8 use less VRAM than BF16. For text to video, there are 2 versions of the 720p model, but you also have a much smaller 1.3 billion parameter model, which can be used in smaller GPUs. If VRAM memory is a limitation, City96 has already prepared a set of GGUF quantized models that can be used. Just remember the quantized models need to be downloaded and installed in the Models UNet folder in ComfyUI. Again, all the info and links in the description. For more information about using the models, check the Wan GitHub page. Wan can be run without custom nodes, but we will use these packs in this tutorial. Install them by going to the Manager. Click on Custom Nodes Manager. Search for the node and click Install. Do this for all the node packs. When finished, restart ComfyUI and refresh the browser. Everything is ready. Come back to the ComfyUI examples page and drag the image of the fox over ComfyUI to load the text-to-image video. In the Load Diffusion Model node, check and select the model you want to use. We will start testing the regular text-to-video 14 billion parameter model. Next, make sure the text encoder in the Load Clip node is the right one. Do the same in the Load VE node. And now your positive prompt. For text-to-video I prefer to use a rather descriptive prompt. Shorter prompts tend to result in lower quality videos. In the example you see the negative written in Chinese. A simple Google Translate shows that these are regular negative prompt words to improve the quality of the video. We will just keep them as Wan works in Chinese and English. We increase the sampler steps to 40. Let's change the video dimensions to have a vertical video at 480p. Width is 480 and height is 720. We will also increase the length of the video to 49. In order to save the video in MP4 format, we will use the Video Combine node. Remove the WebP nodes from the default workflow and connect the image port of the VE Decode node. Change the frame rate to 16, add a prefix for the video and change it to MP4 format. Run the workflow. The result is a short clip of a woman putting on her sunglasses. Let's test now the 1.3 billion parameter model. With this model, depending on the seed, you may end up having bad results with oversaturation. In my tests, reducing the CFG value to at least about 5 reduces the possibility to have bad results. The 1.3B model can still be very good, like in this example. Nevertheless, being lucky on the seed is important. To use the quantized models from City96, Add the GGUF UNET loader and select the model. Connect it to the model sampling SD node in place of the load diffusion model node. Like before, the quantized models seem to work better at a lower CFG. Wan can produce pretty neat results, whatever model you use. The best results are obviously using the 14 billion parameter model and at a resolution of 720p. However, generations can be very long. Fortunately, you can use cache methods like T or first block. In this example, we add the apply tcache patch node. Hovering over the node, we can see what are the recommended parameters for different video models. In the case of Wan, we will use 0.45. Then just connect the node to your load diffusion model node. Let's increase the resolution by setting the width to 720p. To keep the proportions, we set the height at 1080p. While the video is of high quality, take into account the seed is still important. The model sometimes hallucinates and creates artifacts. In the ComfyUI examples page, you can also find workflows for image to video. Like before, just drag the picture and drop it over ComfyUI. We will use the same prompt as used in the previous examples. Load the correct clip model. We select now the 480p image to video model. We will also reduce the CFG to 5. For Wan, use the Clip Vision L model and the Load Clip Vision node. We need a reference image. We select this one in the Load Image node. For image to video, we need to use the Wan Image to Video node, which is connected to the prompts and the case sampler. In this node, we also define the latents. We set the width at 480 and the length at 720. We also reduce the length to 49. Like before, we will also use the Video Combine node to save our videos. We will also add the apply tcache patch node to speed up the generation. You can now run the workflow. Our image has become a video very easily using the image to video models of Wan. For longer videos, you can use the Apply Reflex Rope Wan Video node from Kijai. With this node, you can further increase the duration of the videos without looping and minimizing artifacts. Connect the node to your model output before the K-sampler. You also need to connect the empty latent as an input to the node. This is a different example with the drawing of a cat. For this case, we will increase the duration to 161, which is around 10 seconds of video. The longer the duration, the longer the generation time. This 10 seconds video took me more than 1 hour. And that using 48 GB of an L40S virtual machine in Runpod. Nevertheless, the results of Wan Video are amazing. Thanks for watching.